work the My Crypto stuff, but today we're going to talk about some of the other things we've been working on, including the Eac Ico Starter, some improvements we've been making on the Chronos protocol, which is our new advanced version of the Ethereum alarm clock, and as well as our progress we've been making on pushing the Ethereum alarm clock to a 1.0.0 release. So to begin with, we'll go ahead and jump right into what our developer Daniel has been working on, which is the Ethereum alarm clock ICO starter. So this is a way for developers who might be looking to, or companies who might be looking to do an ICO to easily and seamlessly integrate the Ethereum alarm clock scheduling into their ICO contribution phase. So what this is a easy all-in-one contained starter kit, which will give you this button to put on your page that will be directly using the Ethereum alarm clock scheduling service by default. Now this is also configurable by developers. So even though it's a contained starter kit, I'll show you in just a minute that all of these parameters that you will be able to be set by you. So how does this work? And I'll show you how to use it as well. So it's as easy as just acquiring this library. There's two ways to do it. You can either git clone, which I'll show you the GitHub page in just a minute, and you can also download it from npm. And once you get this library, you'll import it into your project, and you'll have the button available to use. So there's the parameters that you'll need to set. These include the basic values for a ICO contribution, such as the amount of Ether to send, what contract to send it to, as well as some of the stuff for the actual design of the button. And once you have all of these parameters set up, you just add a simple global variable function, and then you have this button available to use. So I'll go ahead and show you the demo that we have put together here, and I'll show you how easy it is to get this button configured and set up for your own ICO. So first I'll just show you the GitHub page here. This is the easiest way to get the ICO starter. You just clone it from GitHub using this GitHub link, and then you have the README down here, which will show you some of the basic use cases of it, as well as go through the steps I just talked about how to import it into your project, and then some documentation for the developers for each of these parameters. So you can follow these instructions and you can have this up and running pretty quickly. Another cool part is that we have a actual demo configure page, which I'll show you right here. This is a way to enter in the parameters and then have the code ready for you to just copy and paste from here into your own project page. So here you'll be able to set a lot of the parameters, such as the contribution amount. This can range from a variety of values, from 100 Ether or more down to a small amount of Ether. You can also input the contributor wallet address, as well as the smart contract address. Since this is intended for ICOs, usually there'll be a buy method. So you can input your buy method into the method signature. So if you have a different method signature here, maybe it's not buy recipient, maybe it says something like just buy, you can just change that here. Maybe it says buy and it also has a value attached. You can configure that in this configuration demo, and you can see this is reflected into the code as well. So once you get this configured, what you'll have is this button down here to allow you to send a contribution. This button by default integrates with MetaMask. So let's say your MetaMask is logged out, for instance. This button will become unavailable to use. So you just won't be able to click it. No one will be able to use it if you don't have MetaMask on. But once you log into your MetaMask account, make sure you're on the Coven test network. And this button will be available to click now, and you can send a transaction through. You can send a transaction here, confirm it with MetaMask, and once that transaction is mined, you'll even have a callback, which will show you that that transaction was successfully processed, and it will give you that transaction hash so you can look into Etherscan and verify it yourself. So this is something that's really cool, and we're hoping a lot of projects might want to use this for their own ICOs, as well as possibly different use cases in the future. Right now it's configured to use ICOs, but with this method signature and with how the alarm clock protocol works, this button could potentially be used for many different use cases, ranging from sending tokens or whatever else. So this is one step into what we hope might be a wider ecosystem of ICOs using the Ethereum alarm clock as a contribution tool. And we really hope developers take a look at this. So moving forward, we've also been working on the Chronos protocol, namely the claiming mechanism. So I'll actually jump to another presentation here, and I'll walk you guys through what we've been working on for the claiming mechanism for Chronos. So if you attended last week's webinar, you heard a little bit about how this works. This will show you a visualization more of how you can use your day token to enter in bonds, which will allow you to claim with your time node. So I'll show you how that works here. So let's take, for example, these three time nodes, X, Y, and Z, each with different balances, 50, 175, and 300. So time node X here will enter in a bond of 50 day into this priority queue. So this priority queue will organize which time node can claim a transaction next. The way this queue is organized is by the bonds that the time node sends in. So let's consider time node Y sends a bond using its day of 175. So the way this priority queue is programmed to work will send that bond to the front of the line. So now that that bond of 175 day is more than 50 day, it'll be the first one that will claim a transaction. Similarly, for time node Z here, it could submit. Now it doesn't have to submit its entire balance of 300 day. If it looks into the priority queue and it sees that the highest bond is only 175, it can just send a part of its balance because it knows it only needs to send part of its balance to get to the front of the queue. So in this example, TimeNode Z submits 200 day, and that's enough to push it to the front of the queue. And what do you know? It has 100 more a day, which will give it another bond in this queue. So once these bonds are in place, we can look at the actual scheduling that will go on with the Chronos protocol. So we have users on the right here that start sending transactions into the that they want to be scheduled for the future, and the scheduler produces these scheduled transactions. So because the priority queue just pops the first time node off the queue, it'll, for this first scheduled transaction, it'll use the Z1 bond and it'll assign it to the scheduled transaction. Similarly, it'll just go down the line. So the next one is time node Y, and it'll continue on until all of the time nodes are assigned new scheduled transactions. So the way the executions now work, this kind of interesting feature where it's almost random when these window starts will be. So there's a little bit of a randomness worked into the protocol here. Let's say TimeNode Z got lucky and it has the first execution set to be executed at block 4500. These are just example numbers here. So this works similar to how the alarm clock works. The time node is allowed to execute and it gets rewarded the bounty, and it also gets the bond that it submitted back because it executed what it bonded and staked that it'll execute. And then we follow down the line. Time node X does the same thing, gets the bounty and gets the bond back. Now we take into consideration, what if time node Y disappears? It goes offline or something, and now it can't execute the transaction it was assigned. Well, in this case, the purpose of the bond is to now incentivize the other time nodes to see that this transaction hasn't been executed. During the execution window, they'll reach a certain point where time nodes will begin to actually try to execute it themselves. And what happens here is that because time node Y is offline and can't execute what it staked to execute, it'll lose part of its bond. So for example purposes, this is half of its bond. This number might change. It might be dynamic. We're still experimenting with how much of that bond will actually be lost. But for now, for example purposes, we're using just half. And then time node Z go ahead executes its second transaction. And sometime later, we have time node Y come back online and realize that it missed the window for its execution, but it still has some bond left over, so it go ahead and just reclaims the bond. And now it has less day than before, but time node X down here, because time node X was online the whole time, it now has more day than it started out with. So this isn't the perfect solution yet. We're still it's still a experimental phase, but it's the direction we're kind of working toward right now. We still have a small problem with miner front running, and we also need to consider whether the volume of scheduled transactions will be higher than the amount of bonds in the queue, and whether this is a problem and how we can mitigate this. But that's about where we are now with the next claiming mechanism. So wanted to show that to you guys so you could get a little taste of where we're going in that regard. And let me just start this here. And so the third thing we've been working on this past week or so has been pushing the alarm clock to a stable 1.0.0 release. So I'll go into a little bit about what that meant from a developer perspective and what you can expect for the next couple weeks there. So we've been going through the protocol and making a lot of optimizations. There's been a few bug fixes and a lot of smaller updates to both the smart contracts as well as the EAC.js libraries. These have been for a variety of reasons, but one of the big reasons is the optimization of the time nodes and quicker loading speeds on the DApp. So with these new optimizations, you'll have much faster experience using the DApp, especially the scheduled transaction scanner. Before, depending on how many transactions were scheduled, that could slow down with a large amount of transactions. And with these updates, you'll no longer experience any slowdown. Everything should be much quicker in the DApp. But what have these optimizations looked like from a protocol standpoint? So one of the major things that have changed in the last week has been using a event-driven architecture. So this has actually led us to a 50% decrease in gas costs from where we were at before. So the Ethereum alarm clock protocol was costing about just under 1 million gas to schedule. We've taken out a lot of the unnecessary storage calls, and we've reduced this to somewhere around 500,000. So it's been a huge optimization for that. And since we're going to be integrated in my crypto, this will be really big for saving people a lot of gas costs. Another optimization we've made is grouping each of these scheduled transactions into buckets. So this helps us out a lot from a DApp perspective. So this is the reason we're able to make the DApp much quicker with fetching the transactions for the scanner. Before, we had to do a lot of parsing through logs, and now we're able to just get the transactions we want to display because they'll be in a bucket, and we know how to look for that bucket. So this helps us on the DApp perspective, but this also helps us from a time node perspective as well. So the same idea there is that the time nodes no longer need to look and watch for each transaction. They just need to watch for the transactions in the buckets that they know will be coming up soon. So they can pay attention to a lot less and thereby be much more optimized to just follow the transactions that they immediately need to care about. And from there, we can open it up to a Q&A. If anyone has questions, we can try to answer those here. So let's see. If you have a question, you can go ahead and ask it, and we'll answer it live. So, okay, question just came in from Fernando. How much USD does Dave? So we can't answer the market questions here. Try to keep the questions to a technical standpoint. But where can it be traded? So you can check Telegram for a full list of exchanges. One of those is HIP ETC, and check Telegram for the exchanges, please. Okay, let's see. So Felipe Castanguay, since ordering the queue costs gas, the longer the queue, the more expensive. How to prevent griefing where a time node could generate hundreds of small bonds and clog the queue, increasing the price for everyone. These bounds would not get flushed out since they would never reach the end of the queue. So yeah, this is something I've been thinking about as well. So because the bonds are attached to the day token, there's what I think would happen is something similar to a gas price market. So if people see there's a lot of smaller day token bonds in the priority queue, they'll start submitting higher and higher bonds. So if there's a lot of one day token bonds, someone with 2-day token could come in, submit a 2-day token bond, and they'll be put to the front of the priority queue. So I don't really view the hundreds of small bonds as actually clogging the queue, as more of just creating a part of that something similar to like a gas price mechanic for the Ethereum protocol, with instead using day token in the priority queue. Fernando, you can join our Telegram. We'll send you a link there. There we go. Okay, so Stan asks, is bonding automatic or do you manually have to look at Q and decide what to bond? So the bonding will be automatic with the TimeNode client. So just like right now with the TimeNodes on the Ethereum alarm clock, they'll send out claims if they're profitable. We'll have the TimeNodes for the Chronos protocol do something similar. The main difference might be there might be a little bit more tweaking for the parameters. So you can say, for instance, submit bonds to a certain amount of day. So maybe you don't want to submit bonds that are higher than 5-day token. You should be able to set that with the new TimeNodes. So yes, it'll be automatic, but there'll be a little bit of configuration as well. That's just to adjust to your own kind of risk profile there. Okay. So I think that looks to be about the end of the questions. If anyone has